Well, I'm Michael Lindstam. Good morning, everyone. I'm the CEO of Aptahem. And I will take you through Aptahem briefly, how we started, where we are, and where we're going. But most formally, I would like to talk about Apta1, our lead candidate, and its unique abilities to be a potential candidate against sepsis. So, we were founded 2014, made a public appearance 2015, and we are a biotech company. So we are addressing life-threatening conditions where inflammation and coagulation is a factor. And that means we have a group of aptamer drug candidates with very unique abilities. We are sited in Malmö, and we have been there since 2014, as I said. So, a little outlook what happened. I will not go through everything. You can talk to the team, which is here afterwards at the break. But anyway, 2014 founded, and we did it on anticoagulants. And anticoagulants showed fantastic abilities with Apta1. And down the road, we found more and more information that also pointed out that it was an anti-inflammatory agent. And that meant that, we have a fantastic combination. So we put it in the worst model we could think of, namely a sepsis-like model. And the outcome was shockingly good. Super survival. So here we are at something. So 2017, the company made a strategic decision to change to focus on sepsis. So from there on, we have been going with new fantastic results to support Apta1's potential. And also, we built a great team. We had made good collaborations. And now we are here. And recently, we released a big report, 200 pages, that confirms and fundaments everything we have seen so far and also new, interesting findings. Let's see. This is wrong. Oh, there. Sepsis. I already said sepsis, perhaps. This is an awful condition to be in. The death rate is very high. There's a lot of people getting struck by this, indirect by different sick conditions. It could be cancer, it could be pneumonia, whatever. This is an indirect effect mostly, and usually bacterial struck. Many dies from this, and there's no cure. So there's three big, very strong points of the unmet need, and it's a global, very big unmet need. So, company rethought this whole idea about how could we possibly use Apta1 as a potential drug candidate against sepsis. Yes, we did that 2017, and since then we've been going on. And on the right side, you can see how many incidents in Europe we have, 1.2 million, close to half die. This is serious stuff. And 30 to 45% actually doesn't get the correct cure that can give you an aftermath. If you survive sepsis, you can be in big trouble. The dialysis, amputations, and so forth. And it has a big, big burden on the socioeconomic system. Family members, colleagues at the work, and also the aftercare. It costs us enormous money, except also the personal suffering. I just want to say something here now, and that is Apta1 is not the one target candidate against sepsis. It's a multi-target candidate, and I will go soon into this why it is like this. But most efforts in this area have been on one target candidates, and so you will see here soon. There. First, a little about Apta1. It's an RNA aptamer. And what does it mean? Yeah, small fragments of RNA has built into a specific target protein and built a very strong specific structure that binds very strongly to the target proteins. And generally, aptamers are very non-invasive. So they just go through the body, do nothing if there's nothing to attack, which has to do with the target proteins that it's been modeled after and tailored after. And so far, we haven't seen any big side effects or anything out of this. And this is just an example how Apta1, as you see, quite an advanced structure, many active sites because it's multitasking. And it just specifically binds in very strongly. So, before we talk about how Apta1 works on the sepsis case, or the potential sepsis case for the Apta1, is how does sepsis work? And we try to very briefly go through what's happening. We see two stages here. First stage is in coagulation and fibrinolysis. These are the two systems that regulate the coagulation. You need to make clottings in the system, coagules, and then you need to declot them. And that is a system going around all the time. If that gets struck out of balance, you have a problem. And the body will react following to this unbalance that we have. And Sooner or later, that will lead to an inflammatory response in the body, which is stage 2. And here you see all the stages. Stage 1, sepsis in the middle, severe sepsis. And when you come into the inflammatory stage, when it runs out of control of the body, it gets dysregulated, you have a septic shock. And that means you are in big, big trouble. And why do we get into septic shock? Yeah, well, when you get the inflammatory response on the vascular wall, where there are coagulants sitting, then you have an inflammatory response, and that leads to tissue breakdown, and tissue breakdown breaks down the vascular, and the vascular starts leaking. Hence, what will happen? Yeah, blood pressure goes down, and at a certain level of lowered blood pressure means you go into shock. And shock means that you have not efficient oxygenation of the tissue and the organs. You have an organ failure, and you die, sadly enough. So you see here, septic shock is the last stage before you actually pass, if you can't take it. And DIC is just an abundance of coagulation clots in the system, and that can lead to a massive stroke. You can die of that too, if you don't die from bleeding or the shock itself. And death we talk about. So I talked about one target. Here is plenty of one targets that failed, both in the stage 1 and stage 2. So remember, we are a multi-target, and here we have the solution, at least as we see it, the potential solution to address sepsis as a very, very life-threatening condition. We take care about the coagulation, we counterbalance the system. So it can stop coagulation, it can help dissolve the clots. In the inflammatory part, we can press down pro-inflammatory cytokines. We also have a stimulation of the body's own system, which is a fantastic feature. So Aptahem does something magic. Of course, we know a lot about how Aptahem works in this system, but I just want to say that if you have questions, the CSO is here, sitting here in front, can take questions later. And of course, read on our homepage and other things. And we hope to come back with a longer presentation, not 10 hours, but certainly longer than 10 to give a better insight into our technology. But what this means, we have a tissue repair, we protect the organs, we have a maintained blood pressure, no shock, potential survival. Fantastic. So yeah, we have some new insights. We just recently released a report on the NHPs that we've done, and it's a massive report. And it contains a lot of facts. And I want to say that it confirms a lot of the things we've seen so far. It shows new indications. And we just strengthened our beliefs in that this is a very potential drug candidate. And some new things that we see is actually the potential for the body's natural system to protect or repair tissue damages. And also we have this fibrinolytic effect. This is a fantastic feature to be able to balance the body's coagulation system so it doesn't run away to clots or anything like I just said. Anyway, we also see another thing that may play a role in autoimmune conditions, and is that we can clear or we can stimulate the body's particular proteins to actually clear dead cells, apoptosis, that the body is working with. It's a very interesting feature. That may be a third patent family in the making, but we will see. We will come back to that when we have that if and so. Patents I talk about, we have 2 patent families. The first patent family is about the structures. We have 3 structures, whereof 1 is the lead candidate we're working with, Aptahem. And then we have the second patent family, which is an in-house invention. Inventor sitting here, you can talk to her afterwards. It covers a lot of therapeutic use, and it was published this spring. So you can go in and read this publication, of course, and take more in-depth information from that. And this is very important for the company, of course. This is a very high-valued position to have patents. That is do or die in the process of finding a partner. Anyway, third family may be on, but we have a very long protection as we speak. So we're very happy about that, and we try to prolong that with new patents, of course. So looking at this market, yeah, we need a market, and I just mentioned partners. Partners is needed to take it all the way to market. It costs billions of dollars to get something on the market. So we need to have a very good evaluation here and potential market. And we have, look at the figures here. This is just an example where we address just immuno-related drugs in the treatment of sepsis. Not any antibiotics or systems that get up the pressure to keep oxygen in the system. No, so these figures could be higher. And look at this, 32 in Europe and 11 in US when it comes to immuno-related drugs. So there is something for us to catch more if we have the success we want to have. The team, fantastic team. Without the team, I would be nothing. I can say that immediately. Amazing team we built during the years. Very seasoned people, very skilled, fantastic to work with them, and not everyone is here, so. And to wind up, we just have a warrant going on, and we had a strike price announced today, actually, and it will be exercised now from tomorrow, Friday, yes, to the 11th of November. And I hope you join us in that. And just to round off totally, we have things going on. We're waiting for a big batch of Aptahem that will kick in the GLP talks that we need to finalize the total safety talk studies to go into clinic. Thank you very much.